All right, so does anyone have any questions you'd like to go over for this review session?
I would like to go over some of the nested loop problems.
Nested loop problems. Yeah, we could certainly go over that. Um, and again, Lauren's going to be in the chat answering any questions you write in chat. Yeah, so she's going to be monitoring that and, speak up if you'd like to, unmute yourself. That's perfectly fine. So, I'm gonna start sharing screens. I I do have a few practice problems from when I took Akinlar's 111 class, so I could use some of those, unless any of you have any specific nested loop questions you'd like to go over. Just let me know. Either one is fine. All right. Um,
Yeah, I'd
so I
say
can.
start with the questions you have in mind, and if anyone
Mm-hmm,
has any ones that they want to add, again,
mm-hmm,
feel free, let us know in the chat, or if you want to speak
mm-hmm,
up, either's totally fine.
mm-hmm. All right. So this this is a sample of some of the questions uh, I've seen. So I guess we could start with the first one. That could be fine. Um, just gonna have to move this. Okay, let's use the online C++ compiler. It, GDB online can work for this review session. So when it comes to nested loops, you're gonna need kind of a good foundation on looping constructs, especially for for loops, like how the syntax works, and stuff like that. So we could start with the first question. I know that for the 111 midterm that Akinlar uses, a nested loop is definitely going to be um, on that midterm. So let's start with question number one. We're gonna write a complete C++ program that asks the user for a number n and then prints a picture showing a triangle that points to the right that has 2 times n minus 1 rows and n columns. So for example, if n is going to be equal to 4, then this program would print this type of pattern in specific. So this is kind of an infamous question, but when I look at a nested loop problem, I think the first thing that I look for is kind of the dimensions of the pattern we're going to be writing. So in this case, we have 2 times n minus 1 rows, n columns. So first things first, to get that number, we're going to obviously need to prompt the user for an input. So let's go on this little tool here using namespace std. So now that we kind of have the body of this program, again, we need a complete C++ program. We can't just write, nested for loops. We're going to need to include the whole, the whole body. So first thing first, we're going to initialize an integer n, and then from there, we're gonna prompt the user for an input. And then from there, so this is going to be the output, and then inputting, we're using cin, and then inputting into that integer n. And so now that we finally have the variable, the value for n, we're able to start this nested for loop. Okay. And so typically in problems like this, you would have like two loops. There are situations that we can get to that require like three nested for loops. And we could certainly get into that. But in this case, we're just going to be using a loop for your rows, which is going to have 2 times n minus 1, and then a loop for your columns. So that's going to be n columns. All right. So let's start with the header of this loop. So it's going to be, we're always going to have to like initialize an iterating variable. So in this case, let's do r for rows. And then r goes all up until 2 times n minus 1. And then we're going to increase by 1 every time.
Excuse me, I have a question. Sorry.
Yeah. Yeah, of course.
Oh wait, it seems like you did it already. Because I was gonna ask, uh, because usually when it comes to like algebraic equations, I guess it would be understood that if you just put two next to n, like I guess it's just
Mhm.
commonly understood that it's a variable. But
Ye-
computers can't read the
mhm.
two just attached to it. You have to put a multiplication sign next to it, right?
Yeah.
Okay.
Yeah. Um, yeah, it's a little bit of like syntax where you're gonna have to multiply specifically by
I'm
n.
I'm
Um,
taking the preparation.
I guess that's equivalent to like how in math we
They
say
gave me a book.
2n. Again, we do have to keep that in mind.
Right. Does that need any parentheses or anything like that, or like would I have to put a parenthesis over the 2 times n?
Oh, sorry, could you repeat that? Two parentheses times 2 times n. No, you don't have to. You could for sure, but this kind of knows like the order of operations. It's going to be 2 times n first, and then from there you go minus 1. All right,
Thank you.
first. And then, so for our next loop, that's going to be these columns here. We're going to do basically the same thing, except the dimensions are going to be different. It's going to start at n, so it's, or it's going to end at n columns. And then from there, C++. Okay. So now that we kind of are in the loop, we also do have to keep in mind that whenever we're finished with a loop, especially when it comes to like ending with columns, we're gonna have to see out a new line, and that just returns to like the next row, so that nothing is printed all on the same line. We want to like split it up into a pattern. Okay, so just keep in mind we do have to like create a new line character every time we finish like a row, for instance. And so, okay, when I see a pattern like this, what helps me a lot is kind of like um, putting it sort of into like an array. Um, like on the side, when you're like maybe taking the midterm or something, you could like um, kind of like make kind of a visualization of what's going on inside this like nested loop. All right. And it can sometimes help finding like a pattern, especially for these nested loop questions, because you're really the main thing is like finding what is the pattern. When do we like print a star? When do we not print a star? And things like that. So I'm gonna make like a little bit of a scratch work here on the side so that we could like visualize kind of a pattern and what's going on specifically for this pattern. Like it looks like a tree or a horizontal tree. So we see that we could start with the first columns over here. And remember that you're gonna have like rows here. I'm gonna make this a little visually more appealing for everyone so you could see what's going on. And then these are your columns. Oops. Gonna All right. So we could start with like numbering out the columns. And sometimes you can start your for loops with a 1. Sometimes you could start with a 0. It really depends on what type of problem and what you're kind of looking for. In this case, I started with 0. But if needed, I could also change it to 1. All right. So in the first row, we're printing 1 star. In the second row, 2 stars. And then so on until this 4th row. Okay. So when we're looking at a pattern like this, notice maybe when you in lecture you also saw some type of patterns where if the columns are less than or equal to the rows, then you would print out a star, right? Because notice 0 is less than or equal to 0, right? But would 1 be less than or equal to 0? No, so you wouldn't print a star. Same thing in this second row, right? In row 1 in this case. We could try 0 is less than 1, so you print a star. 1 is less than or equal to 1. Sorry, I should include less than or equal to 1. So you also print another star. 2 is not less than or equal to 1, so you would not print a star. So in this case, what you could include in your nested loop is that if this column is less than or equal to R, then you would print out a star. All right. Otherwise, you would print out nothing. And let's test it out to see if we got the same output. So yeah, so while these bottoms rows aren't like the pattern, the top ones are, right? They're the exact same as the first 4 rows in the example in the practice problem. So since we got this one right, we're gonna now have to focus on this bottom row, these bottom rows, basically. All right, so we can kind of use this scratch work and kind of change it to look like this, all right? This is gonna be row 0, 1, 2, 3, 4, 5, and 6. So let's change the row numbers first to 3, 4, 5, and 6. That should be, yeah, 0, 1, 2, 3, 4, 5, 6. Okay. So these rows are corresponding to this pattern after here, after these rows. Hopefully you understand that. And then the columns stay the same because there's still going to be the same amount of columns no matter what. There's just n columns. Okay, so at row 3, we have all the stars printed. So something like this. And then in the next row, 1 less star, next row, another less, 1 less star, etc. So it's kind of like this like echelon pattern stuff, like, you know. And so let's see if this pattern, like this rule, can work. Let's see if column is less than or equal to R, then you see out a star, right? But column less than or equal to R is 3, so U less than or equal to R. So it does seem to print out a star. But you're gonna need another condition for this, all right? So for this pattern, you're gonna need another condition because this unfortunately is not correct for the bottom. All right, so when you see something like it goes up and then like a pattern seems to go down, you're typically gonna need like two conditions. In this case, C is gonna be less than or equal to R. And then for this bottom of the staircase, I guess what we could also do is like start let's see if like rho less than or equal to C could be true. So 3 less than or equal to 0, you would not print out a star. No, you would not print out a star. So you'd probably print out stars like in the opposite pattern. Like see how the triangle kind of moves this way? You can also, I guess this is the pattern that changes it to like this type of triangle. So that wouldn't be correct, unfortunately. But let's think about C being less than or equal to a certain rho. I'm noticing that if we change the iterating variables to start at 1, then maybe we could multiply this column by 2 or this row by 2. Let's start at 1 instead. Again, so these types of problems require a little bit of like trial and error. Because sometimes you can start at 1, sometimes you could start at 2. Start at 1, sometimes you start at 0. Apologies. But yeah, so if you start at 1, your rows are going to go 1, 2, 3, 4, 5, 6, 7. So this row will be 1, 2, 3, 4, 5, 6, and then 7. So it would go, all right. Seven. Okay. So now that we shifted every row kind of closer to 1 instead of 0, I think you can multiply this number n, because notice how our n is going to be equal to 2, right? Equal to 8, right? Or 4. N is going to be 4. So when you multiply that by 2, you get a number 8. So that could kind of like, if you subtract 8 from each row number, so 8 minus 7 is 1, right? 8 minus 6 is 2. Now, do you kind of see this pattern where this one kind of corresponds to the index of the column where the pattern ends, where the stars end? So 8 minus this row number, which is 5, gives you 3. And then 8 minus 4 would give you 4. So we see that 2 times this number n, which is used for the number of columns and for the number of rows, if we multiply that by 2 and we subtract a row number from it, then we get the column index of where the stars end for the bottom of this pattern. So if we combine this bottom with the top pattern that we found, then maybe this could possibly work. Let's see. So if column is less than or equal to R, the row number, then we print the top pattern. And we also have to include this like caveat for the bottom part where if this column number, if C is less than or equal to 2 by the input number minus R, because I'm noticing that 4 is less than or equal to 4, 2 is less than or equal to 4, 3 is not less than or equal to 1, so we would not include that. So we could try this, test it out to see if this works. Or it'd be or. We could see if we should use and or, but pretty sure we should use and for this condition. So we could do C is less than or equal to, what was our pattern? 2 times n minus 4. 2 times n minus r, apologies. Let's see if and or works. Remember that these like double bars is like or, and then the double ampersand is going to be your and, all right? Let's try 4. I think that was our, okay. So we just get the whole n by 2 times n minus 1 pattern. So I guess let's try and, because you kind of have to fill the condition that the stars have to be within this range specifically. Okay, let's try and instead. For 4. Okay. All right, so I think and does seem to work in this case. Well, because you're going to need to fulfill a condition that if the columns are less than or equal to the rows, and they're also less than or equal to 2 times the input number minus R. All right. So that takes care of problem number 1 for this like nested loops practice problem. Does anyone have any questions regarding this? It does require
Wait.
Oh, yeah, sorry.
Okay.
Do you have any questions regarding problem number 1? It requires a little bit of like thinking through like the pattern. I think what helps really is this kind of trick where you kind of like visualize.
Wait, I'm not talking about that.
Sorry, where were you talking about? Do you have like a question or?
Can I just share like the screen for a while?
Yeah.
Wait, let me just let me see if it wait, let me just
I also took a screenshot of the code and put it in the
Mhm.
chat for you guys. So if you want to look through it, there is a screenshot in the chat.
Yeah, thank you, Lauren. I saw
wait, where's
Abdul.
the
Abdul, you said, sorry, I joined late. What was the goal of this for loop? Oh, the goal of this for loop was to print this same pattern. We found, we basically, the first thing we did was prompt an input. We inputted a number into the console. From there, you begin your nested loop. So you should start with the rows. Then from there, you begin with your columns. And then from there, we found these 2 conditions where the columns have to be less than or equal to the rows. And also these columns have to be less than or equal to 2 times n minus the number of rows. And this condition,
okay, never mind. I don't have a question anymore.
you don't? Okay,
No.
that sounds good. I guess We could also try another nested for loop problem if
There
you
was a student who had a question about problem 4.
problem 4. All right. For the nested loops.
Yeah,
Was it this?
I believe it was that one, yeah.
Okay. Got it. We could go
How
over this
likely
one.
of a how likely is that one even to be on the test though?
Oh, sorry. Which question? This question? Number 4 or
Yeah.
number 1?
Four.
For I'll be honest, when I took Akinlar's midterm, I think the pattern was pretty similar to this one from what I recall. So we could go over this one. But honestly, I think any of these are kind of fair game. I don't think the pattern should be incredibly difficult, as in like, oh, you can't solve it within like a class, like an exam period, but that's just what I think. And I think the pattern that I had specifically was similar to this one. So let's go over it. So we're gonna write a complete C++ program that asks the user for a number
Wait,
n.
you're skipping 2 and 3?
Yeah, we're doing number 4 for a student that asked about it. So then it prints n triangles made of 0 symbols. So the symbol 0, one above another. Each triangle has n rows, and the triangles are alternating upside down from each other. So alternately upside down from each other. In the way shown below, the triangles should be separated by a line of stars, star symbols. So for example, here's the output from a program where the user specifies 4 for n. Okay. And also we do have to try to keep this program as short as we can. So we're gonna try to do no more than 30 lines of code, all right? So let's
But that's still
start.
kind of a lot though.
For the number, the lines of code. Yeah, 30. I think you can make this type of program in a few lines of code, but let's try to
But what do you
make
mean
this as
by
short as
few lines
possible.
of code?
Like I guess make it a little bit more efficient. Like you can output the same thing with fewer lines of code. I think
Okay.
that Akinlar posted solutions for these types of practice problems from when I recall. So you could also like go through them in like your free time. So let's start with this problem. So we're just gonna first ask for an input. So we're gonna see out, enter a number n. Okay. You output, like you prompt the user and then you input the number. So then it prints n triangles made of 0 symbols, one above each other. So each triangle has n rows, and the triangles are
And I think
alternately
it only
upside
prints
down.
out 4 triangles.
Yeah, so notice that there's 4 triangles with 4 rows and 4 columns. So when I see this, that there's going to be 4 triangles with 4 rows and 4 columns, I'm thinking we're going to need 3 loops for this one. So recall in the last problem we did, there were 2 loops. We're going to, for this problem, need 3 loops only because we're going to be alternating the triangle patterns.
Okay.
So we're going to start that. Let's first start with the iterating variable for the number of pattern or the number of triangles, because we're looking to print this. And then we're going to separate them with a line of stars. So I'm going to start these triangles. Let's say we start them at 1. And then the triangles go all the way up to n because like the problem asks for, we go up to n.
Excuse me. I
Oh,
just
yes.
looked it up. Why start them off at if triangle is supposed to be the amount of triangles that get printed, why start it off at 1 instead of 0?
Um, in my experience, I feel like it depends on the type of like problem you're asked to do. I think either way, you could start at 0 or 1. It'll be the same thing. It's just you're gonna have to keep in mind to change the like upper bound for the loop. So if you start at 0, you're gonna want to go up until n, not including n. But if you start at 1, you're gonna want to go up until n, but you're gonna include n. It's gonna be the same amount of iterations this way. It's just when you're like calculating like a pattern, notice in our last example, it was easier to start at 1 only because 2 times, what was it? 2 times n minus like the number of rows was kind of an easier calculation when we didn't have to think about the columns being 0, you know? Um,
Right.
typically I would, oh, sorry, yes.
I was gonna say, so if we were to start at 0, it would be just triangles or what,
Mhm.
less, or like equal or like less than n, or
Yeah. So if you start at 0, this is equivalent to starting at 1 and then going up until n, including n. Because you're gonna do the same amount of iterations. So let's type on the side, like for instance, if n equals 4, right? And we start at 0, then we're gonna go 0, 1, 2, 3. We're not gonna include n because look at the condition. The triangles
what
go
about
until n.
what about 4?
4 is not less than 4, so we're not going to include 4. And then if
But it said we need 4 triangles.
n equals 4 and we start at 1, let's say that we start at 1 in this case, we're gonna have to change the upper bound. We're gonna do 1, 2, 3, 4. So it's the same amount of triangles. Do you all see that? It's still
Mm.
4 triangles, you're just starting at a different index. And in this case, we're just gonna focus on like the number of triangles, not specifically the index. Do you see that?
so it doesn't really matter where you start. You just have to take out or add
Yeah.
equal. Simple.
Mm-hmm.
Okay.
Yeah, basically. Okay. So we created this for loop specifically for the number of triangles. And then notice that we're gonna have to make two loops for the triangle pattern. And then after that, we're gonna make that row of stars. And then we're gonna go through another iteration of the triangle loop. So I'm gonna write out here we are making the triangle code, the pattern code. And I'm just gonna first start with making these line of stars because this is kind of like the cutoff point after every triangle. So let's pretend that we finished the code for the triangles first. All right, so this is the code. We did that. And then after that code for these, so after this is printed, what I'm gonna do here is just print out this row of triangles. All right, so we could use a for loop for that to print out those stars. So let's say int stars is equal to 1, and the stars go all the way up to n. We go stars plus plus, and then we just see out a star. And that's going to print out these rows of stars after each triangle, okay? And then we're gonna see out a new line.
Right.
And if you can see that if you can see when I run this, we're gonna see a row of stars. All right, so this takes care of this star issue, all right? So now
Wait.
oh, sorry. Could you repeat that? Could you repeat that? Did you have a question or?
No.
Okay. So we start with the stars, and then let's go back to the triangles, okay? So here we're going back to the triangle code.
No.
Recall in the last problem, we used two loops, one for the rows, one for the columns. So let's start with the rows. So for int r equals 1, let's start at 1 this time. R goes all the way up until n, including n, and then r plus plus. Okay. Make another for loop for the columns, of course. And now we could write into the body of this code. So I'm noticing that this pattern is alternating every other triangle. Okay. So I'm gonna visualize this. So this is pattern 1, right? Because we started at triangle 1. This is triangle 1.
Huh.
This is pattern 2. Okay. And then this is pattern 3 again. And this is pattern 4. Okay. What do we notice? Oh, yes.
Sorry, it's just like a very simple, like, ultimately, wouldn't it just be like, if you go back to the code really quickly, so ultimately we're just alternating between, the two. Okay, ultimately we're just alternating between the two. What do you call it? Ultimately, we're just alternating between the two triangles, right? So we're just basically going to be setting up two types of for loops within the R loop, basically. Two C loops within the R loop to basically draw out the triangle. And in between that, it should print out a what do you call it? Oh, you're checking for spaces, basically, I see. Okay, never mind.
And then print out the triangle.
So you're right. We're checking to see like when it alternates. All right.
Wait,
So
where's the else code?
the else code, we're going to get to that. So notice that when the pattern's 1, we do this type of triangle. All right. It's kind of like oriented, I guess, to the right. And then when pattern 3, it's also oriented to the right. So, but it's different when it's pattern 2 and pattern 4 because those are oriented to the left. So notice that whenever the pattern's odd, it's oriented to the right. And whenever the pattern's even, it's oriented to the left.
Mm-hmm.
Do you see where I'm getting at this? So if the pattern is yes,
so the odd points down and the even points up.
yeah, you could also visualize it like that. I'm just saying right and left only because this is how I see the triangles as like the odd patterns are to the right, the even patterns are to the left. Okay. So we could use actually and a condition like an if statement so that if this pattern, if the triangles are odd, then we print this out. If they're even, then we print this out. So we could check for the parity or like the whether a number is even or odd by using modulo. So if triangles mod 2 is equal to 1, because we're starting at pattern 1. So if this is odd, this is how we check for if it's odd, then we're going to enter making this pattern. All right. And then else if the triangles, the pattern number is even, so if triangles mod 2 is equal to 2, then we are going to make this left shift type of triangle. Do you see where I'm getting at this? All right.
Well, you measured if it was mod. Okay. Can you
Yep.
explain the logic behind the mod 2 again? Like exactly how you got to that?
Yeah, of course. So remember that the modulo operator gives you the remainder of whenever you do a type of like integer division. Okay, like for example,
Right.
for a modulo, let's say we're doing like 3 divided by 2. What's the remainder when you get 3 divided by 2?
1, you got the
One.
remainder of 1.
Yeah, exactly.
Wait,
You're gonna get the remainder of 1. So
It hasn't printed
this,
out the 4 triangles yet.
yeah, we're gonna write that
uh,
code in a bit.
okay, also, I just kind of had a question. Wouldn't
Mm-hmm.
it have to be triangle mod 2 equals 0 instead of 2?
Oh, yes, sorry.
Yeah,
Apologies.
that's you see that was where I got
Right.
confused on. Yeah. Because
My apologies. I was thinking of mod 2,
because you were
but yes,
thinking it
you're
was
right.
even, right? You were thinking of it as
Right.
even or odd. So
Yes.
for it to be
Mm-hmm.
equal to 2, it wouldn't exactly define it being even.
Mm-hmm. No, that's actually that's correct. Apologies for thank you for noticing that. But yeah, so if you do like 2 mod 2, you're gonna get 0, which means it's even. All right. So that's what I mean. So let's look at the odd patterns first. We have I could make like a diagram like we did previously. I'm just going to,
Oh, don't tell me internet went out.
sorry, could you repeat that?
No, my internet was just burning out. Sorry.
Oh, okay, that's fine. All right, so in this case, we started at 1, so let's start indices at 1. All right. So this has 1, 2, 3, 4 columns, 1, 2, 3, 4 rows. All right, so it's the same deal as before. Gonna use these dots to symbolize our stars. And let's try to find this pattern. It requires a little bit of problem solving, but we see
2.
all the stars in row 1 are printed. Meanwhile, there's only 1 star in the 4th row that's printed, and that's when it equals the column 4. So it doesn't include any star when the row is less than or equal to C. Or wait, let's try. Yeah, if the row is less than or equal to C, or alternatively, we could just say C is greater than or equal to R. Then 1 is greater than or equal to 1. So this checks out. 2 is greater than or equal to 1. 3 is greater than or equal to 1. So we got this entire row is printed with this condition. Alternatively, if 1 is 1 greater than or equal to 2, no, so we don't print a star. 2 greater than or equal to 2, we do print a star. 3, 4, etc. So noticing that with using this condition, C is greater than or equal to R, we can make this type of pattern towards the right. All right. So let's type this out into code. So if it's an odd triangle, and
Okay.
let's combine these conditions actually. So if the triangles are odd, the
Okay.
column is greater than or equal to the row, then we're going to see out the
Yeah.
O. Pretty sure that's an O, right?
Okay. See out the O.
Looks like an O.
Okay.
Yes. Likewise, to make this type of pattern, we could do the same thing. I'm pretty sure this should be if R is greater than or equal to C because it's flipped. See, it's flipped. So I'm pretty sure we could use R is greater than or equal to C, but let's see if that works as a pattern. So R is greater than or equal to C. So 1 is greater than or equal to 1.
The
True.
zeros have first appeared, but
So
they still have make a triangle.
yeah, it still makes a triangle.
Doesn't make a triangle.
This rule, this condition, or
Yeah, the fourth code.
the fourth code? Oh, for number 4. I'm not entirely sure what you're talking about, but right now I'm using this condition to see if it works for this type of pattern for when the pattern is when the pattern number is like even, all right? So we're checking to see if the row 2 is greater than 1, greater than or equal to 1. So yes, we print it out. 2 is greater than or equal to 2, we print it out. And etc. You could try it with the rest of these stars. So we found the pattern for when the triangles are even. So, and that's going to be when the row is greater than or equal to C. So from there, we're going to do the same exact thing as from the previous triangle. We're going to print out O. And pretty sure if neither of these work, then else see out a space. And always recall that you're going to need a new line character after every iteration of a row, okay? So let's see if this pattern can work. The original was 4. Oh, and yeah, so as you can see, we managed to replicate the pattern. Does anyone have any questions about this code? And we managed to actually write this within 30 lines of code too, so that's also great. About 26 lines. 25 lines. All right. Does anyone have any questions? Hopefully the student that asked about this has a little bit more clarity. Triangle.
Yes.
Yeah, so notice that this, I'm going to section off the code. So notice that these lines were after every triangle is printed, we want to print out a row of stars. Just stars, it doesn't matter what the condition is. So from there, after we print this triangle, we're going to print out the stars, okay? And then after that, we're going to make a new line character just as we did for the triangle so that we can enter a new triangle pattern iteration. Hopefully that answers your question.
Yes. Thank you.
Of course, no. Jean, do you have a question?
I did 24 lines.
24 lines?
Mm-hmm.
Yeah, that's also good. As long as you're able to like replicate the pattern, when it comes to these types of questions, you can for sure have like different answers for the nested for loops especially. So that's good. All right, does anyone have any other questions regarding this question about nested loops? Maybe there's like other questions you'd like to try. Let me know. All right, so I'm just gonna look in the chat really quickly. Is the midterm gonna be mostly about loops? I would say that loops are a decent chunk of the midterm from what I recall. Definitely nested loops are going to be a question, but also just regular loops. And if you'd like, we could go through a looping question actually, because I do have some looping questions here that we can go over. All right. If you'd
Before we
like, we could
get-
try.
Yeah,
Can
before
we
we
try
get
number? Oh,
oh, sorry, go ahead, go ahead.
I was gonna ask if we can do number 3.
Number 3 for the loops
Yes.
or for the nested loops?
Regular loops.
Okay. Yeah, we could do that. All right,
Before we
so
get started with that, I just
Wait.
want to mention if we could possibly, if everyone, if anyone hasn't filled out the attendance form, it's really important that you do fill it out. Also, since this is about the middle of the session, I understand people might have to leave. We also have a feedback form. So if you have a minute and have some feedback that you'd like to give us, we really do appreciate it. It helps us improve our sessions.
Mhm.
And yeah, if in case you have to get going, and that's totally fine because the whole thing is recorded, so you can always go back to it later on. So if you have a minute, we also have the feedback form.
Wait, we're gonna do number 2 now.
We're for the loops, we're gonna be doing number 3. But yeah, exactly as what Lauren said, we do ask that you fill out both the attendance and the feedback form, just so that you know you could get maybe some like advice on how to like improve these sessions. It also helps us keep track of like how many people are attending like these sessions, so that the Learning Commons knows that there's it's like still demand and stuff like that for
Okay.
these courses. So that would be greatly appreciated. Thank you all.
Okay.
And I'll just give like another minute for you all to fill that out, and then we'll start number 3.
Can you do question number 12 after this, the nested loop?
Yeah, we could do that. This one?
12. 1, 2.
Oh, 1, 2. Oh, number 12. Apologies. This one?
Yes.
Okay, we could do that next.
And also, again, I'm in the chat, so if you have any questions midway, you can always ask me in the chat as well. So I'd be more than happy to help.
All right. I'm assuming that the majority of you have filled out those forms, so we can get started on number 3 for the regular loops. Because yes, loops are going to be a decent chunk of the midterm. So let's start with this question. Write a complete C++ program that asks the user to type an integer n, and then it should ask the user to enter n more numbers and print the average of these numbers. So partial credit given to programs that perform some of the required steps, but excessively long or complicated programs lose credit. All right. So let's take this step by step. First thing we're going to do is ask the user to type an integer n. So let's go back here, n. Then we're going to prompt the user enter
no.
an integer. Again, like how we've been doing, just prompting for an input, putting that input in. Okay. So then it should ask the user to enter n more numbers and print the average of these numbers. So this is just saying like, it's kind of like prompting again. Enter, let's say the user enters like 4. It's going to say enter 4 more numbers. So we could do that. So we're going to see out again, output, enter. What was the now enter? Okay. N more integers. All right. So this is how we kind of get the output to enter these numbers. All right.
Integers.
So we're gonna have to enter in numbers and then print the average of these numbers. So we're gonna be using a for loop. And
Okay.
for loops are really helpful when you kind of know like how many times you want to run the loop. So in this case, we're gonna want to run them n times. We're gonna want to run the for loop n times. So let's try int, this iterating variable can start at 0 time. Let's say 0 just to get some practice. And then I goes all the way up until n. And then we're gonna go I++. And then inside this for loop, let's think about this conceptually. We want to ask the user, or we're going to allow the user to input an integer, okay? And then from there, we're going to add that integer to a total. And so we're gonna have to do that by creating kind of a sum variable. So int sum should start at 0 because I'm assuming there's no like negative integers, but either way, we could just start this sum off at 0. And what we're also gonna do is if we want to ask the user to input an integer, we're gonna need to create another variable to input a number in. Let's call that number input num or something. All right, let's set that equal to 0 too. So in this line of code, we're gonna in to that input number. Input. All right. From there, we finish this part. We're gonna add that integer to a sum. So we're gonna do sum plus equals input. All right, and recall that this is just equivalent to sum equals sum plus input. This is just a shorthand. All right, so this is kind of how we thought through this problem by entering n numbers because this for loop is going through n times. And then from there, we're going to use that input num. We should stay consistent. Input num into, we're going to add input num to the sum. All right. And now that we have the sum, we can, what was the original? We're gonna print the average. Okay, so we need to print the average. And then we could do that. We could do like, wait. So the average should be a double. So the double average. And recall average, you're gonna get your total divided by the number of inputs. Okay, so remember that our number of inputs was n. So that stays. And then our sum, we could typecast that because remember, wait, all of these are integers. So we're gonna have to typecast to double. Double sum. And then that sum divided by n. All right. That's how we got the average. And we could see out your average, or their average is blank. Their average is going to be this variable average. All right. So we started off asking the user for a number of inputs. We asked the user to input an n number of inputs. We added the value of those inputs into an integer sum, kind of doing like a running sum, and then we typecasted that sum because it's an integer, so always remember to typecast to a double because we don't want integer division. Then we divide that by the number of inputs, and it should print out. So enter an integer n, let's stay consistent. Let's say 4, enter 4 more numbers, 5, 6, 7, 8. Their average is 6.5, right? All right. So this type of problem requires just a loop, just a simple loop. We don't need anything nested. Anything like that is not really necessary. So hopefully that answers your question regarding number 3 for the just the regular loops. All right. Let me know if there's any questions regarding this.
Wait.
Yes?
Let me just let me just mm, wait, let me just
If you don't mind my asking, why did you convert the sum to a double variable type?
Because we don't want integer division. So remember that sum is an integer and n is an integer. So if we divide an integer by an integer in C++, let's say we do like 3/2.
It would automatically round up, basically.
It would round down basically. So we just get 1 instead of 1.5. So by changing at least one of these operands to a double, we're kind of ensuring that like no information is going to be lost that way.
Yeah, but okay, and you just left n as an integer variable type,
Yeah,
basically. Okay,
yeah,
gotcha.
that's fine to do. As long as one of the operands is a double, there shouldn't be any problem.
Gotcha.
Yeah.
but here
Any other questions?
yeah no.
No?
In
Okay.
the chat, it was asked if you could go over question 28 and 41 of nested loop.
Oh, you have to like
20,
space the numbers.
28 and 41.
Yeah.
Okay, 28. So 28 is this, and then 41. Right, we could do 28, 41. Okay. Yeah, we could complete these. 28. Okay. Write a complete C++ program. Oh wait, I'm assuming it's 20 as in 0112 because I noticed that there's two different numbers. Hopefully these are the correct ones to whoever asked, but I'm gonna start with this one. So write a complete C++ program that asks the user for a width W and prints a white arrow pattern made of spaces against a dark background made of X's. Okay, so for example, if a user specified 5 for W, then the program would print as follows. Okay, so I guess I would say just first look at like kind of the dimensions of the pattern. We see that's 1, 2, 3, 4, 5. So it'd have 5 columns because W is 5, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, that could be 2 times W minus 1. All right. So I'm gonna delete this program.
Is that question 28?
Yeah, this is question 28 on nested loops. So let's first just, as usual, as we've been doing, prompt the user for input.
Mm.
What was the enter a width W. Okay. And this time we're just going to change N to W to just remain consistent with the problem. So we're going to have a white arrow pattern against a dark background made of X's. All right, so it's kind of the reverse of what we've been doing, where if like a condition is true, then we print a star. But in this case, if a condition is true, we can just print nothing. So let's start as we've been doing, int. Let's start with the rows. Let's say rows is equal
Oh
to
wait, let me
1.
just miss.
Rows is less than or equal to W, our width, and then we just increment by 1. And then we make another loop, int, the columns start at 1, they go all the way up to W, and then columns increase by 1. Okay?
No.
All right. So similar to the first problem that we've done, remember that kind of like horizontal Christmas tree? We can sort of like split this problem up until to like 2 kind of conditions. So let's start with the top of this pattern. All right. So that's going to be about the first 1, 2, 3, 4, 5 rows. All right. Let's say 5 is going to be all the way down here. Okay. And then we just make 5 columns. Wait, how many columns? It was 5. Okay.
Huh.
Okay. So notice that in the top, the first half at least, we're not going to print anything diagonally. So that's kind of equivalent to the diagonally seen over here. All right. So this is when you print something. This is kind of like the inverse where, you know, you don't print something here, but in this case you print something. It's the same thing. So notice whenever the rows and the columns equal each other, then, you know, something happens. In this case, we print like a dot. So when 1 equals 1, when 2 equals 2, when 3 equals 3, etc. So for our condition, if the row is equal to the column, then, you know, we're gonna print out just a space, right? A white space. Else, we're gonna output an X. All right. And then after every row, remember we should end line. Okay. Let's see if this pattern works. We could always adjust it, but based on the sketch that I made, it should likely work. Okay, awesome. So we were able to find the top half of problem number 28, at least like the example output, where every diagonal going from left to right is going to have a space. Okay. And now we're going to need to get the bottom of this diagonal, or the bottom part of the pattern. So we could do this just by extending the number of rows we have. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 rows. So we're going to do 2 times W. Okay. All right. Or I guess it's less than or equal, or it's just less than W because we're not including the 10th row. We're just going up until 1 through 9. Okay. Okay. So now we're kind of gonna do like the opposite here, because in the example, we see that it goes from right to left diagonally. So let's start. We start at index 1. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes 5, 6, 7, 8, 9. 6, 7, 8, and then 9 here.
Oh, excuse me.
And yes.
If I'm being honest, I'm not really a big fan of the whole grid visualization. But is there any other way you could look at it, really, that you know of? If not, it's okay. I'm just curious.
Oh, like you're talking about like on the side, it's not really helping you.
Yeah, no, I'm not really a
No,
fan of
I
it.
understand that. I understand. I guess for me personally, it helps kind of like breaking the problem down into chunks. But I guess when you start doing a lot of these types of problems, you notice that a lot of just of these conditions are repeated. Like notice how in the diagonal, like you're just gonna see like a lot of repeating rules. Like in the diagonal, you're really gonna see like if row equals column, then you're just gonna get, you know, a printed star or something. And then here, I'm also seeing that like if you add like this column plus this row and it equals a certain value, then you're gonna print this diagonal right to left. Again, I guess this visualization just it for me personally, it's the only thing that I really know of, aside from like practicing a lot of problems. Yeah.
All right, thank you.
Yeah, I understand. It may not work for everybody, but yeah,
Can you
sorry about that.
explain,
Yes.
can you explain why it's like rho is less than 2 into W?
Which part again? Could you explain that?
You just wrote now. The rho is like less than 2 into W.
Rho is less than 2 times W, because looking at the dimensions of this loop, we're gonna see so there's 5 columns, but every time there's like 5 columns, we're gonna see 9 rows. So 5 times 2 is 10, and then if we subtract 1, I guess we could subtract 1 and then make this include 9. So we get 2 times W is 10 minus 1 gives you 9. All right. Same thing if we did like W equals 4, we'd get 4 columns and we get 2 times 4, 8 minus 1. So we get 7 rows when we have 4 columns. Does that answer your question a little bit?
Yes.
Okay, awesome. Do you have a question, Jane?
Wait, I'm trying to see if it goes, if it works.
Okay.
Wait, but no, but
All right, let's go back to
well,
if you,
the line only moves diagonally instead of bouncing back. I mean, the blank space.
the blank spaces. Yeah, I mean, if you're looking at the top half, then yeah, it moves diagonally from right to left.
I move it to the other way diagonally.
And then yeah, so we're gonna do that right now.
Okay.
I'm just like when we're doing this,
Aren't you just essentially doing 2 for loops within the initial, like, if you go back to the code really quickly.
Right.
So based on what you're building, right, you're essentially doing
Mhm.
2 for loops. You've already completed this loop as you kind of matched the first half of the
Yes.
directional line. So instead, what you're going to essentially do is invert the
Hmm.
logic backwards.
Right.
So you
Right.
create, so you'll just have to copy paste this for loop, but change the stipulations instead.
Wait,
Um,
what for loop?
So yeah, it's gonna be like a different condition, but you don't necessarily have to copy and paste the for loop. You don't have to make like 2 for
Oh,
loops in the
it's
sense.
nested. Okay, I just noticed that.
Yeah.
Okay, gotcha, gotcha.
You don't have to like copy and paste and this change the condition. You could write all the conditions within one for loop. We're just gonna have to write like a compound conditional statement where
So would
if
it be
R,
or?
yeah, we'd
Yeah.
use or.
Okay.
So like when the rows are equal to the columns, then the top half prints, and then for the bottom, we could do something like, notice that like, okay, so this is 0, 1, 2, 3, 4. So this is the fourth.
Yeah, because the blank space makes sure that
I'm
it
gonna
goes like
write this down. So
one
this
row
is
by one
so
column,
this is
2
4,
row by
right?
column.
Oh, could you repeat that? I wasn't able to hear that.
I think it goes like by the only blank space only covers the ones that are equal to the row column, like 1 column to 1 row, 2 column to 2 row, to the third row to the third column, the fourth column to the fourth column, and the fifth column to the fifth row.
Yep, that's exactly what we did over here. And that's for the top half. So now notice that when the column is 4 and the row is, I guess we started at 1, so let's change this to 5. Apologies. Let's change row to 5 or column to 5. Apologies. So, and then when column is 5 and the row, what's this row number? This is 1, 2, 3, 4, 5. Oh, would you look at that? Okay. So the column is 5, the row is 5. Here, the column is 4 and the row is 6. Okay. I think I could just type this out instead. It could be a little bit easier. Here we said column equals 5, row equals 5. Here, column is 4, row is 6, because it's still going to increase. Column is 3, and then the row is going to be 7. Here, column is 2. We're starting at 1, remember, and then row is, wait, 1, 2, 3, 4, 5, 6, 7, 8, 8. And then the last one, when column is 1, row is 9. Okay. I guess this is another way of visualizing without having to do an array to the student that asks kind of a question without having to draw it out. I guess you could also like think about it numerically. Notice that the columns, in this case, the columns decrease in the second half and then the rows still increase. So, okay, wait. Let's look at what happens when we add the rows and the columns together, okay, everyone? So we see, look at column plus row. 5 plus 5 is equal to 10. And then here, it's the same thing. 4 plus 6 is equal to 10. Okay?
Wait, I
3
kind of
plus
I got
7.
figured out like a rule. So wait, would it be like every time that like column plus row equals 10, it print a space pretty much?
Yeah, that's what I'm noticing too. So yeah, no, that's a good point. We could do if R is equal to column, but then if you mentioned R plus C, right? So if R plus the column is equal to, let's not make it 10. How about instead we make it so that like this loop can work for any specified W. So we could do like 10 divided by 5 gives you 2. So we could do like 2 times W. Do you see what I mean? And that's in this case equivalent to 10.
Would that still also, would what you had before also still work? Or
For 10, I think, yeah, no, it still worked for this specific example, but if we change W to be like 4, I think it would change. We could try it out. But yeah, so I guess in a way we could also think about it numerically. 5 plus 5 is 10, 4 plus 6. So in this bottom half, when the row and the column are equal to 2 times that width, then we, excuse me, then we still print out that store. Okay. Let's see, it was originally 5, so. Oh, would you look at that? Excuse me. So we got the pattern for both the top and the bottom half. We just had to kind of combine the two conditions for us to, be able to print out a space. Does anyone have any questions?
Yeah, sorry, I just came in towards the end.
No
So
worries.
we're given the user to input the width, and then towards the end we would just multiply the width by 2, so it makes the program a lot more flexible instead of just setting it to 10.
Yeah, because 10 I think should only work for like when W is 5.
Yeah.
So let's try it like when W is like 4 or something. Yeah, so the pattern's going
Yeah.
to be a bit different here.
Okay. Okay. So it just makes it more flexible by letting by multiplying it by. Okay.
Yeah, basically. Yeah, basically.
Thank you.
All right, does anyone have any other questions regarding this question?
Yeah, one more. Sorry. I just noticed the outer for loop. It's for the condition when it's checking for when row is less than or equal to 2 times width minus 1. What is the minus 1 for?
So notice that in our example, I'm gonna move all the things I wrote down so that you all can see it. But basically notice that there's there are 5 columns, right? Whenever
Yeah.
we say 5. Let's count the number of rows. There was 1, 2, 3, 4, 5, 6, 7,
5 is
8,
the middle
9.
row.
Okay. Yeah, 5 is the middle row. So we're kind of thinking of a way to get 9 rows from the number 5. And you could just do that by multiplying the width by 2 and then subtracting 1 from that.
Oh, I see. Okay.
Yeah, of course.
All
And the
right,
width
thanks.
is obvious, it's going to change. So then the
Yeah.
row numbers are going to change. So,
Gotcha.
yeah. All right. So, we're done with this question. Again, I do want to mention to please fill out the attendance and also feedback forms for us. I understand that it's also getting maybe a little bit late for some of you. You have to leave, so again, please do fill that form out. If you do have to leave, I guess I'll give everyone a minute maybe to anyone that hasn't done that. And let me know which question or any topic you guys want to go over, like if you'd like to do anything for this next half hour. Yeah.
I know that it hasn't really been brought up, but I think title lines and functions are often a really big topic on the exam.
Yeah, we can do that.
Yeah, so if anyone else doesn't have any more questions on the nested loops and stuff, I think it would be good to just do a little bit of those.
Can you do question number 12? I asked earlier actually.
Oh, for the nested loops?
Yes, I
Oh,
asked
right,
her.
of course. I apologize. Yeah, you did say that. And we could also do a little bit about like the function signatures and stuff like that. That is also part of the exam. And we're gonna do that after we finish the next question. Okay. It should be question number 12. Also, if anyone has practice questions involving like the function signatures, please feel free to send that. Again, if you want to go over that, that would be great. Okay. So let's do this question number 12. Okay. I guess this will be like our last nested loop for the day. Write a complete C++ program that asks the user to enter a positive integer n. If n is not positive, the program should print a message not positive. Enter another and continue to do this until the user enters a positive integer. So notice within these instructions, you're kind of going to need to do like a validation loop. And so if you recall, maybe Akinlar talked about it during his lecture, but we're going to need to use like a validation loop, so kind of like a while loop. So that's kind of just that's going to be for this part. And then the program should print n squares of stars with decreasing size that begin with an n by n square and then with an end with a 1 by 1 square. So the right-hand edges of the squares should line up, and then partial credit given to parts of the program you complete successfully. Excessively long solutions like might lose some credit. Okay, so let's start with the first part, checking, validating the input. All right, so let's enter a positive number. All right, and so now we have to check if it's positive. So if it's not positive, so if it's like less than or equal to 0, then we're going to enter this validation loop. All right. Now from there, you keep on inputting a number until n, and we could see if this works, Yeah. So now it finally works. So that's how we know that our validation loop works. All right, run. Remember, we're always going to need a condition to stop this while loop because we don't want any infinite loops. All right, so then the program should print n squares of stars with decreasing size that begin with n by n square to end with a 1 by 1 square. The right-hand edges of the squares should line up. Okay, so similar to the triangle problem we worked on, I think it was that first one, we're going to need 3 for loops. All right, so it's going to be 3 nested loops basically, because we need to keep track of how many squares there's going to be. All right, so there's going to be like, here there's 1 square, there's another square here, there's another square here, and this is technically a square too. All right, only because this is technically a 1 by 1 square. All right, so let's just write on this really quickly. So let's say that this is square 1. This is square 2. This is square 3. And then this finally is square 4. All right. Size, I realize. So if it's 4, or 4 times 4, here it's a 3 times 3. From there. Okay. So let's start with our outermost loop. So that's gonna be the square, like how we talked about over here. So let's start, well, square 1 is going to be 4 times 4, right? We mentioned square 2, it's 3 times 3, and so on. And then this should be, I think, 2 by 2. Okay. So I guess we should start at the number n, since it starts at 4. So we start at n, right? So it's a little bit different from the previous nested loop questions we've been working on. Square is equal to n. And then square should continue up until 1, because we're beginning with n by n, and then we're ending with 1 by 1. Okay, so that's how we kind of got this header over here. So then we're continuing until the square is at least 1, and then from there we're going to go square minus minus. Okay,
Hey,
instead of
question.
Yes.
Wait, so if it's the decrement, why isn't it a square is less than or equal to 1?
Is less than or equal to 1. Notice, so, oops. So I'm gonna put on the side, let's say n is equal to 4, okay? So square is equal to 4. And then notice this condition over here. So is 4 greater than or equal to 1?
Yeah, it is. That's true.
It's kind of gonna be an infinite loop, I see, or if 4 is less than or equal to 1. Sorry, I mean to say 4 is less than or equal to 1, because you were talking about the opposite, right? So
Right.
4, this loop is never going to run if we do the opposite. Okay. If we do greater than or equal to, then this loop should run at least like n times. In the opposite way, it unfortunately never runs, because unless we have n equal to like 1, it's not going to run, unfortunately. So that's kind of where we got this header for the loop. All right, for the outer loop that keeps track of how many like squares there are. Okay. And I guess we could do the same exact thing with like the rows and the columns. Or not the same exact. I guess we could start at 1, just like how we've been typically doing. We could do r equals 1. And then r goes up until the square, right? Because r should go all the way up until it starts at 1, goes up until n. And then we go r plus plus. All right. For the inner columns, do the same thing, start at 1, go up until n, c plus plus, and then from there, we now have to figure out the conditions. So, I need to plug my laptop really quickly, but
Need battery charger.
yeah, thank you for mentioning. Yeah, okay. So, okay, so that's fine. All right. So notice that the squares should be printed whenever. Let's see what would happen if we just did like see out like a star. I do wonder if like this could I'll see out just a blank space, and then from there we should do like a new line character for the loop. Let's see what this prints out whenever we type in the example integer. So in this case, we said 4. All right. Oh, I said else by accident. Apologies.
Oh.
Let's just type in, well, there's no condition, so how about we just keep it as like star? We just type out star for just to see what this looks like. It
Oh
should
no.
probably just be like, oh, I think I pressed in a really big number. Let's try 4. Okay, so this prints out an integer 4 all right, so it's just gonna be a rectangle. I'm assuming the number of
Yeah.
rows in this
No, I think
example.
it's gonna be like
Yes.
a very long rectangle. Just how wide depends on the number input.
Yeah, exactly. So the number of rows here is just going to be like how many rows there are over here, I realize. So we're
But
not gonna
but only put like a 4 times. How many are there?
we could do kind of a trial and error, but basically we don't want to print out these
Yeah,
spaces,
print out
right?
like a 4 times 16 rectangle, even though they're supposed to be like decreasing over time.
Yeah, you're right. It should be like decreasing. Hold on.
Shouldn't that just be solved with like a decrement operator?
Could you repeat that? A decrement operator?
Yeah. And the
Where do you?
instead of C++, maybe C minus, I
Mhm.
think. Maybe.
We
I
could
don't know.
try that. Yeah. Oh, so this runs an infinite loop, I think.
Yeah, never mind. Okay.
So I think um we I guess we should keep it at C++. I do think we should decrement the square continuously, but I think we should go all the for a row, we should probably go up instead of n, instead of going up until like 4 rows or something, should only go up until like we hit the square, like the square variable. So for instance, when like square eventually is gonna be like 2 or something, then this row only prints out uh it's probably only gonna print out like 2 rows or something. We could try this out. Um okay. So again, it's a long it's a bit of a shorter triangle now. Or triangle. Oh my gosh, apologies. Rectangle or rectangle. I've been thinking about triangles, but it's just a long rectangle now. But what we want, is these n by n squares. So we're gonna need a condition for this. So instead of just printing out the star whenever um, we're printing out a column, let's do like if this column um let's let's break it down into chunks, I guess. So if the column is going to be like, so we start at 1, 2, 3, 4, right? Or 1, 2, 3, 4. So it's always going to print because it's going to be bigger than, I guess, our input number 4 minus the square. Because we started the square at n, right? So if we do like 4 minus 4, that's 0, right? Oh wait, let's think about this. So like say
I
column. Oh yes.
I was thinking maybe if like since we're doing if we're decreasing the squares, wouldn't the one of the conditions, well at least in this case, row would be row is less than or equal to the square, and then that way each one that um okay, you got that already. Actually, I just noticed is less than or equal to square.
Yeah.
Um,
I see what you're thinking though. Like we want to make sure that each row only has like the like the kind of the maximum of the square. Yes?
Wait.
Oh. Um so notice that in this first square, our columns are still just going to be 1, 2, 3, 4. So columns are still 1, 2, like those aren't going to change. Our rows are going to change, however. So we need to make, so the columns should be greater, maybe. But what does change is going to be the square. It starts at 4. It goes 3, 2, and then 1. All right. So it goes 4, 3, 2, 1. And notice that see Let's try if column is greater than like n maybe, then we see out
Okay.
the star.
Mm-hmm.
Else we can see out the space. Okay, so this prints out nothing. Okay. Let's try. So the column is never going to be like above 4. So n is going to be 4, but if we subtract a square from it, because in this case when it's square 1, square is 4. So if we do n minus square, we get 0. So then if the column is greater than 0, you'd print a star. All right. We could do n minus that square. So if c is greater than n, I guess we could do if c is greater than n minus the square, right? Or we could do c is greater than the square as a test run, and then from there, if anything, we could. Okay, so we see something printed. It's kind of the it does seem that it's kind of creating like kind of like a step-like pattern that we see in this original example. It's kind of printing out the inverse, however. Notice that the stars here are the stars that are not printed in the original example. Do you see that? So I guess what we could do, we could subtract square from n. All right, because notice that these stars are these missing stars over here. I'm gonna use a pencil so you all can see that. Like these stars over here. Like here, here, here. Those are the same pattern that's not being printed here. So what you could do is instead of it just being greater than square, we could do n minus the square. So we get everything that's not this. All right. Let's see if this runs. I think it should be the okay. So we see the opposite going on over here. So if we just do s, c is greater than square, then we get the stars that are not printed. But if we do n minus the square, then we get the stars that are printed in the example. Okay. Does anyone have any questions about that?
Can you please explain it again? I'm so confused.
Yeah, so I'm just thinking it through in my head, like if we do c is greater than any square, if we do c is greater than any square, then we're just given these stars that are not printed, okay? Because notice that square is going to be 4 in the first. Okay? And so this is 4. Square here is 3, right? Square here is 2. And then square here is just 1. So, and then our C, I'm just gonna show the opposite. If C is greater than square, then you print a star. But notice that none of the columns in the first square are greater than 4. Because 1 is not greater than 4, 2 is not greater than 4, 3 is not greater than 4, 4 is not greater than 4. But in the next column, remember how the squares decrement by 1? So then we have square is equal to
Mm.
4,
Hmm.
square is equal to 3, square is equal to 2, and square is equal to 1. All right, same thing here. So I guess the columns, yeah, so nothing gets printed here because none of the columns are greater than 4. But since 4 is greater than 3, then this gets printed, okay? This gets printed like as seen here, this bottom, this last row, right? And then in the next square is 2, right? Look at the columns, and the only columns that are greater than 2 are 3 and 4. I'm going to highlight these so that you could see them. So it's going to be, oh, I guess the highlighter doesn't work, but you see that this row gets printed, and then after 2, we see that these stars get printed. Because 2 is going to be your square, and any number that's any column number that's greater than 3 is going to be printed. Okay.
Mm.
And yeah, in that last square, the last square is 1, right? So any column bigger than 1 is going to be printed. So then these 2 columns are printed. So if we take the inverse of this, and we do n minus that, we get the pattern, right? This was a little bit of a tricky question, I can't lie, only because you're kind of thinking about like multiple for loops, and in this case you're gonna have like a decrementing square.
Question.
Yes, this is a little bit of a tricky one, guys, I can't lie.
So out of the ones in the whole file for nested loops,
Right.
right? Which ones, if you could look at them and name them by number, which ones do you think would actually be on the midterm?
I think any of these could be on the midterm. It's just there are ones that are trickier than others. Like, for example, I'm sure that during lecture, your professor talked about maybe like pattern number 1 or pattern number 2, because those, are, they kind of require like multiple conditions or something like that. Question number 3 that we went over requires like multiple loops. So that is also another question that could potentially be on a midterm because it's testing your knowledge of like how many nested loops does this require. Same thing with pattern number 4. Pattern number 5 is similar to 3 and 4, except instead of going through the like these diagonal lines vertically, you're kind of doing them horizontally. So it's a very similar technique. Yeah, I mean, I do think any of these are fair game, however. Hopefully that answers your question. I don't want to say that none of these will be on them because, I mean, I'm not the professor, but it is possible that any of these could be on them. It's just, I think it's just testing your knowledge of your basics of nested loops. I don't think it should be too difficult. Yeah. I do notice that we have 1 minute left. And I know that for the most part, we've been talking about loops. But if anyone has any like questions regarding, functions or basic conditionals, maybe other loops, maybe like outputting values like to the console or something, please like reach out to like the Learning Commons and like book an appointment like with like a specific tutor or something. Just like if you need like more help in regards to like those topics,
Mm.
because I do realize that we've been talking mainly about nested loops. So if you need any like more help on those types of topics, definitely reach out to Learning Commons. Okay. But yeah, so it's 2 o'clock, and yeah, does anyone have any questions about the midterm? I'm not entirely sure when your midterm will be, like when it will be, but
It's next Tuesday for us, I believe.
next Tuesday.
Yeah, the
Okay, I see.
21st.
The 21st. Okay. Do you have like an afternoon or like a morning
I believe
midterm?
I think it's afternoon for us, isn't it? Like from 12:15 to like 1:05, I believe.
Oh, okay, okay. Well, you still have like this like weekend to go over these concepts. I from what I remember, midterm 1 was basically these program output, um, some short answer questions if you'd like to go over one, some basic um if conditional if conditionals with looping, and then the nested loop. So there were like 4 questions from what I remember.
The short answer questions are just another form of CPP code, isn't it?
Yeah, for short answer questions, I'm going to mention that, like the instructions say, it's just give like a single line of C++ code, or like at the very maximum, give like maybe like 4, maybe 5 lines of code. I recommend to stay within the 1 to 3 lines of code range, however. But when a question specifically asks for 1 line, then you just give 1 line. And another thing for these short answer questions, just remember like some of the functions that I'm sure that Akinlar like went over. Like for example, like random functions, maybe square root functions. Those are definitely worthwhile to remember. All right.
Gotcha.
Mm-hmm.
I also want to add, so where this video is posted, there's also videos from past semesters as well. So, we kind of went over like different topics in those past semesters. So if
Mm-hmm.
you want to honestly take a look at some of those as well, I'm gonna repost the link in the chat where this video and the others are gonna be posted.
Mm-hmm. Yeah, for previous semesters, like just like Lauren said, you're gonna have same type of review sessions for CS111, especially for the midterm, for previous semesters. So definitely take a look. It's on the Learning Commons website, and I think Lauren posted
See?
the website. You could find them, and they're just this similar format to what we did today.
See?
Oh, he said that he wouldn't go over random or square root. Okay. So I guess whatever your professor mentioned wouldn't be on it. I guess, you know, like he said, I don't think it would be on it then.
Yeah, I think the best way to review for this, I know there's like so many questions to go over, but just
Mhm.
going over like a little bit at a time of each of the main topics. You could
Yep.
definitely expect at least 1 question of each topic to be on. And so
Mhm.
like it might be like some ones that you have to make a function, or you have to make a title line, or you have to like actually do like a nested loop or a coding question. So, be familiar with all of them. But also, after a while, if you do the questions enough, you'll notice that there's a lot of trends. For instance, on a lot of the nested loops, we had the same code structure. We
Mhm.
switched things up a little bit. So essentially, when you do them enough times, you'll get those tricks under control. So best thing to do, watch some more of these videos, do some more of the practice problems, and just keep going. You guys got this.
Yeah. Um, so don't, just like Lauren said, don't get caught up in like just one single type of question. Try to go over like all the different types of problem sets that like you were given. Um, there's going to be a lot of patterns that arise. Just like, inputting like uh inputting stuff into like a variable, checking for like what's being outputted at a specific like position, simple for loops, simple like conditional statements, and stuff like that. So definitely take your time to just try a variety of different problems. All right. Don't get caught up in just a single type. All right. And I hope.
Oh, sorry, go ahead.
No, I wasn't really going to mention anything, but.
Oh, I was just going to mention also, you know, with these questions, like the coding questions especially, it's great because you can check your work on a compiler, right? If you get the right output, then you know it's good. But for some of them, if you're not too sure, you know, it's good to use AI smartly. Like, don't just be like, yo, what's the answer for this? Like, do the problem yourself without any help, and then ask AI, hey, is this answer correct? And if not, what can I do to improve? And you'll find that the AI can be more of like your teacher instead of just, you know, doing the work for you.
Exactly. And so we do have the link that Lauren posted. You're gonna see under CS111 under previous semesters. You're also gonna see for Akinlar's class, midterm 1, for different semesters. And you kind of just get a taste of the different types of problems that have been done previously too. All right. In addition, you know, to the ones we've done today. Okay. And I think from there, I'm going to stop the recording. Yeah. Okay. And also just fill out the feedback forms, please.